everyone and welcome back to my channel. So this is my third video on ligands in coordination complexes. And in this video, we will discuss few more ligand terminologies comprising of flexidentate, ambidentate and the bridging ligands. So let's get started.
Hello friends. Okay, now after discussing the different classifications of the ligands, we have few more terminologies used for ligands. Okay, let's discuss them one by one. As you can see here that I have written three terms: the flexidentate ligands, ambidentate ligands and the bridging ligands. So we'll discuss them one by one. So first of all, the flexidentate ligands. Okay, as you can see this term flexidentate means the denticity is flexible. What is the meaning of flexible denticity? Means denticity, as you know, the number of donor atoms of the ligands. That means whatever is the number of donor atoms for a particular ligand, that number is flexible. As the denticity is flexible, so ligands may not use all their donor atoms, right? That means they can use some of their donor atoms and the other donor atoms are left as such. The very common example of this kind of flexidentate ligand is the EDTA. Okay, so we had discussed previously that EDTA is a hexadentate ligand in general. So it is a hexadentate ligand. So as you can see that the EDTA, which is actually a hexadentate ligand, can act as sometimes it can act as a tetra or a pentadentate ligand in several coordination complexes. So for this recap, I have put a structure of the EDTA that we had discussed previously. So you can see that there are 6 donor atoms, 4 oxygens and 2 nitrogens. That makes it a hexadentate ligand. But actually sometimes what happens, all the 4 oxygens may not be used. So 2 oxygens and 2 nitrogens, which make it tetradentate, and sometimes 1 oxygen is left out. So 3 oxygens and 2 nitrogens, which make it a pentadentate ligand. That means what it is showing that all the 6 donor atoms are sometimes not utilized, which makes it a flexidentate ligand, which can easily change the number of donor atoms as per the requirement or bonding in different kinds of coordinate complexes. Okay, one more example is the sulfate ligand, which can act as either a monodentate or a bidentate ligands in different complexes. So that is why sulfate can also be categorized as a flexidentate ligand. And now next comes what are ambidentate ligands. So how to define ambidentate ligands? So you should not get confused between flexidentate and ambidentate, because they are almost they seem to be similar, but there is a slight difference between flexidentate and ambidentate. So ambidentate ligands, they contain 2 or more donor atoms. Now as you can see, I have written that ambidentate ligands are those ligands which contain 2 or more donor atoms, but during the complex formation they use only 1 donor atom. That means the number of donor atoms are more, but while forming the complexes, only one of the donor atoms is utilized. Okay, now when we see the examples, it will be more clear. So the examples of ambidentate ligands are NO2, so nitrito. We call them nitrito. We'll learn about the nomenclature in the next section. Okay, so we can write NO2 minus, and also we can write this NO2 minus as ONO minus. So there are 2 ways of writing. So what is the difference between these 2 ways? In the first way, NO2 minus, you can see nitrogen is attached to the metal atom, right? While in ONO, the oxygen is attached to the metal atom. So that means oxygen and nitrogen both can act as donor atoms, but when the complex is formed, either oxygen or nitrogen, only one donor atom is coordinated with the central metal atom. And while writing, we write it as nitrito O or nitrito N. Now the next example is the cyanide ion, which can also be turned into an isocyanide. So Cn minus is cyanide, Nc minus is isocyanide. So one of them is nitrogen, another is the carbon. So like this, different cyanide and isocyanide. So one of the donor atom is only utilized while forming the complexes. Now the next example, as you can see, is the isothiocyanate and the thiocyanate ion. So it contains nitrogen and sulfur as the donor atoms. In thiocyanate, so it is the S minus which acts as the donor atom, and in the thiocyanate the nitrogen acts as the donor atom of the ligand. Although sulfur can also act as the donor atom, but in forming the complexes, one donor atom is utilized. So these are few examples of the ambidentate ligands. So I hope you understood the difference between the flexidentate and ambidentate. Flexidentate means the denticity is fixed, like in EDTA it is hexadentate, but in different complexes it can also act as a tetra or pentadentate ligands. Means one hexadentate ligand can also act as a tetra or pentadentate ligand depending upon the conditions, whatever complex is there, whatever metal atom or whatever is the bonding. So depending upon the conditions, it can change its denticity. In ambidentate, there are two or more donor atoms, but during complex formation only one donor atom is utilized for bonding with the metal atom. Now the next term is the bridging ligands. So what are bridging ligands? Now as you can see this example that I have written for explaining the bridging ligands, you can see a complex where we have two metal atoms. Here we have two cobalt atoms, right? So we have two metal atoms, and these two metal atoms are connected with two ligands. One is OH, another is NH2. As you can see, this complex forms a bridged complex. Bridged means these two metal atoms are coordinated or bridged through these two ligands, right? So these two ligands which act as a bridge between the two metal atoms are known as the bridging ligands. How they act as bridge between the two metal atoms? Because they have more than one electrons to coordinate with these two metal atoms. That means bridging ligands should have more than one lone pair of electrons. So if you look closely to these two ligands, one is NH2. So this is the amino. NH2 minus actually it is. So it contains a negative charge and a lone pair on the nitrogen. That means it can bond with two metal atoms through the negative charge and the lone pair. Similar is the case for OH minus also. So OH is the OH negative. So it has lone pair on oxygen and the negative charge, right? So it can also bond with two metal atoms. So like this. So more than one lone pair of electrons for bonding with two metal atoms. These two, NH2 minus and OH minus, these act as the bridging ligands, and such type of complexes which have two metal atoms that can be bridged through two ligands, these complexes are known as the bridging complexes. So hope you understood all these three terms, the flexidentate, ambidentate and the bridging ligands, and hope it helps. Thank you.
So I hope you enjoyed this video. I hope now you have some fair idea about the ligands that we encounter in coordination chemistry. If you have any doubts and queries, please write to me in the comment section. For more clarity, please watch all my videos on ligands in coordination complexes. And please like, share and subscribe if my videos are helpful to you. I will be back with new videos on the nomenclature in coordination complexes. And till then, thank you so much for watching.